Hi everyone. So let us solve today's problem of the day, that is number of following a pattern. Number following a pattern. So what does the question state is that given a pattern containing only one i's and d's, I for increasing and d for decreasing, devise an algorithm to print the minimum number following that pattern. Okay, and digits from 1 to 9 and digits can't be repeated. Okay, so what does the question state is that we have been given a pattern containing i's and d's. So I stands for increasing and d stands for decreasing of the number, and we need to write a function so that to print the minimum number possible by following this order, and we have to use the digits from 1 to 9. Okay, so for example, if we have d, so that means the number should be in the decreasing order, right? So what is the smallest number in the decreasing order that we can take is 2 and 1. Okay, 21. Then let's say we have another example as I, D, D, D. Okay, so in this case we have this particular output. We'll be seeing how it is. So for example, in here we have I, D, D, D. Okay, so output is 1 2 6 5 4 3. So how we are getting is, this is right. First we have an I, right? So is my 2 is greater than 1, right? So if s of I plus 1 is greater than my s of I, so yes, 2 is greater than 1. So first two numbers are in the increasing order, right? Then again we have I. So in that case 2 and 6 should be in the increasing order, right? So 2 and 6 are also in the increasing order. Then we have d. So that means the next two pair of integers should be in the decreasing order. So 6 and 5 are in the decreasing order. And then we have again d. So 5 and 4 are in the decreasing order. And then again d. So 4 and 3 are in the decreasing order, right? So this will be our particular output for this solution. Okay. So, if you go through the problem once before viewing this video, you will get to understand that the very brute force approach that we get in our mind is that every time I am getting an I can just add a number greater than my previous number, right? And every time I'm getting an integer d, I can add a number which is smaller than the existing number, right? So, let us see where this particular brute force algorithm fails, which we are thinking of. So for example, we have S as I, D, 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 okay, and V as this particular. So why this 1, 2, 3, 4, 5, 6? Why am I taking this? Because the smallest number, smallest lexicographical number that we can create using s s length plus 1 length is this particular number, right? The smallest number, lexicographical number that we can create with these numbers is 1 2 3 4 5 6, right? So what is the algorithm that we are going to follow, which we just saw, is that whenever my s of I is equal to I, right? So in that case my the string is going to be increasing, right? So in that case what we can do is check if s of I plus 1 is greater than s of I. So in that case we can continue, right? But whenever we are getting any s of I which is equal to d, so in that case what we saw earlier, that we need to add a number which is less than the previous number, right? So in that case, since this v is in increasing order and we are considering this, if it is not in the decreasing order, we can just swap those two numbers. Let us see what we are talking about here. For example, we have considered the shortest lexicographical number to be 1 2 3 4 5 6, right? So what are the modifications which we'll be doing according to the algorithm which we saw earlier? So let's see that. So first of all, if s of I is equal to I, so I is at 1. So first my I is here, right? My I is here. So at 1, if s of I plus 1 is greater than s of I, so is 2 greater than s of I? Yes. So in that case, my current answer is 1, 2, 3, 4, 5, 6. Okay. Then again, I plus plus, that means my pointer is pointing, sorry, my pointer is pointing at 2. Okay. So now we can check if, again, we have an increasing order. So at 2, we have to check if I plus 1 is greater than s of I. So is 3 greater than 2? Yes, it is true. So in that case, we can just increment the pointer, and we get the current answer till now as this: 1 2 3 4 5 6. Okay. All right, so the current answer that we are getting till now is 1 2 3 4 5 6. Okay, so then again we have a d, that is a decreasing order, and we are standing at 3. that is here, right? So in here we have to check if I plus 1th index value is smaller than my 3, right? If s of I plus 1 is less than s of I. So no, that is not true, right? Because 4 is greater than 3 and not less than 3. So in that case, what we do is we just swap these two elements. So if we swap these two elements, I get the answer as 1 2 4 5 3 6. So let us see if it is following an order. At this point, is this particular sequence decreasing? Yes, it is decreasing. So till now my answer is correct. Okay, so again we have a D over here. So at D, what we can it is at 3 again. So that is it is here, right? According to my answer. So again I will check if it is in the decreasing order, and we will see that it is not in the decreasing order. So the final answer that we receive, right, the final answer that we receive is 124563. So this is the final answer that we are receiving, and let us check if this particular answer as per our algorithm is matching with the current sequence. So first is increasing. So is 1 and 2 in the increasing order? Yes, it is in the increasing order. So then we'll check, we have an I again. So is 2 and 4 is in increasing order? Yes, 2 and 4 is in increasing order, right? Then it is fine. Then we go again to D. Okay, so we have to check if 4 and 5 is in decreasing order. No, 4 and 5 is not in the decreasing order, it is again in the increasing order. So we can see that this particular algorithm which we saw, that every time I am having a value uh, I as I, so that means increasing. So in that case I cannot perform any operation, because I am considering the smallest integer which can be formed using n is 1 2 3 4 till n, right? This is the lexicographically smallest integer. And so this particular algorithm gives me an incorrect answer, right? So let us see what will give me a correct answer. For example, we have this particular test case, right, wherein we have IIDDD, and we are considering the smallest lexicographically smallest number, and we'll be doing some modification in this in order to get our answer. So instead of swapping every time I'm getting D, instead of swapping two numbers, what if we reverse this whole array, right? So at any point I'm receiving a D, what I can do, at any point I'm receiving a D, what we can actually do is, till the time we are having the D subarray, we can take that particular subarray and reverse it, right? So what if I do this? I will get a number as 126543. Okay, so basically I'm reversing this whole array. So in that case, by doing so, we will be very sure that the element which was the last increasing element, its next element would surely be greater than that particular element, right? And all the integers after that would be in decreasing order till the time we are getting a D subarray, right? So this is what we'll be doing. So this matches with our answer that is given over here, right? 126543, we are getting 126543. Okay, so I hope you're clear with this approach, and let's get back to the code which we have written so that you understand it in a better way. Okay, so this is the code that I have written. We have a vector v in which we'll be storing the smallest lexicographical number which we can form using n integers, and we have n equal to size. So we are taking the size, and this is the answer string that we'll be returning. We will first push all the numbers, that is 1 to n, whichever we have, inside my v, and I will be iterating through this particular string which we have. Take the current as I, and till the time my current is not reaching the end of the index values, and s of current is equal to D. Okay, so this is the case where we are getting the D values. So in that case, what we have to do is select that particular substring and reverse it, and then add it to my answer variable, right? So what I do is, till the time we have a D, I will do current plus plus, so that we can consider that particular substring, and from there what we can do is just push the sorry reverse that particular substring, and if that current is not equal to I, so I should be equal to current minus 1. That is, I'm the we are updating the current index, and at the end we can just see the answer. We can just push the answer variable, the v which we have, the answer which we have. So basically we are doing all the changes dynamically in the vector v, right, which we have considered as 1 2 3 4 5 6 till n. So we'll be reversing that particular substring, and at the end we can just push all these integers to our answer by converting it to a char and return the answer. So I hope you're clear with this approach. Thank you.